On these two questions, still walking around the room, I tried to give you time to make sure you do it. This happens every single year. Whenever I do these two questions, I was going to take them off this year, but then I thought, no, I want to see. If you look at the examples above on those problems, what did they tell you to do? Make a table. All right? Now, what happens, Sharice is going through and she's doing it, and she does the first one, and she can use her pretty little brain instead of making a table. So then right after that, what happens on problem 2? Thought the second one was easy. On another problem where it's a little harder, like number 2, even though you didn't maybe need a chart for number 1 to figure it out, probably would have been nice to have one for number 2 to help you figure it out. Now maybe you guys just ran right through it and your brain works different than mine maybe, and maybe you didn't need it. Somebody read me the first one. All right, read me the 3 names again.
Nate, John, Nick.
So we got Nate, John, and Nick. And what's the 3 jobs?
Pet's office, computer store, and restaurant. I don't know, why is your thing like that on the screen?
I don't know. It's
Really
super huge. They changed my projector, and Mr. Poole in here this morning, he couldn't figure out how to make it smaller, so I gotta try to figure it out. Yeah, it's hard. It makes it hard for me to write, but it's all right. What's the first hint that they give us?
One of them
Nate
gets
buys
free
com-
food.
Nate buys computer games.
John.
Nate buys computer games on his way to work. What's that tell you about Nate?
He doesn't
Like
work
he
at
can't
the
get
computer.
He doesn't work at the computer place, so we'll put an X there. What's the next clue they tell us?
One of them is allergic to
Nick is allergic to
cat hair.
Nick's allergic to cat hair, so what's that probably tell us about Nick?
He does not work at the vet.
Let's hope not, right? Not gonna work out too well for him if he does.
One of them gets free food.
One of them gets free. John gets free
Which
food.
means he works at a restaurant.
So let's hope John doesn't work at the vet. If he works at the vet and he gets free food, then that's pretty nasty. Probably doesn't work at the computer store, so we're guessing that he probably works at the restaurant. Is that all they told us?
Yeah, but Nate, if
Well, what do we know right now with what we have here?
Nate works at the vet, they can't work at the restaurant.
Neither one of those 2 work at the restaurant, so now do we know where Nick works?
Computer store.
Computer store, and we know that Nate works at the vet. Alright, and again, could you think that one out in your head? Probably so. The second one, not quite as easy. I think it might have been a little tougher just to think out. And what we're going to cover today, that's what you need to be able to do, is figure out ways to do problems, not just think it out in your head every time. You got to come up with ways. All right, how am I going to solve this? How am I going to get from here to where I want to be? What does the second one say?
6 tenants live in consecutive funds, keep 2 apartments, one is inside their apartment building, and he lives in apartment C. Millie's apartment is just past Scott's. Anita's closest neighbors are Eric and Ava. Scott's apartment is not usually Eric's apartment. Oh, Eric's apartment is before Ava's, and if Roberto lives in the apartment, whose apartment
You don't want
lives
me to
in
take
which
that, do you?
apartment?
After you just told me you were going to be good in my
Why
class.
are you being good?
Put it back in your bag or I'm going to take it. You shouldn't have opened it.
It's been open.
Put it back,
Not gonna lie.
put it back in your bag. Is that all of it?
I could pull more coffee.
What's the names again, Sydney? Thank you. I'm sorry we got interrupted.
Names?
Yeah.
Anita.
Anita,
Kelly,
I'm just gonna put A for Anita.
Kelly,
Kelly,
Scott,
Scott,
Eric,
Eric,
Ava,
that's an A, right?
Yeah.
So I'll write it out since we got two
and
A's.
then Roberta.
When it says like consecutive, does that mean like A, B, C, D?
Right, yep.
Yep.
So, and I better put an N up here because what's our apartments gonna
A,
be?
B, C, D, E, F.
We don't wanna make sure we don't mess those up with the names. What's the first clue that they gave us?
Anita lives in apartment C, so that has to be it.
What else do we know if she lives in apartment C?
Nobody else does.
Eric and Ava.
She doesn't, before we do that, she doesn't live in any other apartment and
Nobody else lives in that.
nobody else lives in C.
Eric and Ava are neighbors versus D and D.
So Eric and Ava
Are her closest
are,
neighbors.
are whose closest neighbors?
Ava's.
Ava's?
So one is
Or-
B and one is D.
So,
Anita is,
so we don't know for sure which one lives where, right? But we know that, we'll write that out here. We know that one of each of those lives in B and D. Alright.
Kelly's apartment is just past Scott's, and Scott's apartment is not A through D, so either E or F.
So like.
So Scott,
Well.
Lives in
Scott
E or
and-
F.
Scott lives in E because Kelly's just
Yeah.
past Scott's.
so Kelly has to be
And
F and Scott has to be in E. What's that tell us?
no one else can live in
He doesn't live in any other.
Nobody lives in none of those, and he doesn't live in none of these. Nobody else lives in there with her, or with him, whichever one that was, and he doesn't live in any of the others. What else they tell us?
And then if Eric and Ava are in B and D, then Roberto has to be in A.
Yeah.
Alright, so we know
that's what-
Roberto's an A, so that means Roberto can't be here, nobody else can be an A.
I
Now
put,
what?
Eric and,
I had Eric in B.
that's why I put,
Yeah, I had
I put
Eric.
Eric and B and
His
Ava.
apartment's before Ava's.
Is that what it says?
Yeah.
Eric's is before
Eric's
Ava's?
apartment is before Ava's.
Alright, so then we know
My Eric's in B.
Eric has to be here, and it's not there, and nobody there, and then that one there.
See, I'm confident I did that a lot easier way.
Keep thinking it's easier. Cause when we do the stuff that we're gonna do, if you don't make a drawing or something, you will be lost.
Are you sure on number
Are
one?
we turning
Because
this
I
in?
think
Or did we already
for
turn
me,
this in?
number
You said wait
one
until
was
the
in
new
chart,
chart.
it made it a lot more complicated.
Number one might have been. I don't think it was more complicated. It didn't take us but what, 15 seconds to do it once I had the chart drawn. So I don't think it made it more complicated. I know for sure on this one that instead of trying to keep all that straight in your head, if you want to make sure you get it correct,
I wrote
This
it
is the
down,
way to go.
but
I just thought.
that's why.
all right, on the homework. If it got smaller. I know what's going on. On the homework, questions, problems you want to see worked off of page 78 or
47,
85.
42.
Which one?
42.
42? Which page is that on?
78.
Page 78, number 42. The sum of two complementary angles is 90. Write the converse, inverse, contrapositive of each conditional statement. Determine whether each one is true or false. If false, find a counterexample.
I just don't know how you would like. I got 40 in it.
42, this is on page 78, right?
Yeah.
So somebody read this sentence to me again.
The sum of two complementary angles is 90.
All right, before we do that, let's write it as an if and then statement, because that's the only way we're gonna be able to do it. So if what?
If
If
sum of
it's-
two complementary angles.
And
If two angles are complementary.
we
then-
could sort of leave part of that out, right? Because it's sort of unnecessary if you write it with the if. If two angles are
Complementary.
complementary,
Then the sum.
And then
And
the
sum.
sum of measures.
how about the sum is what?
90.
90. You guys try to fit every word in there that they give, and sometimes you gotta make little changes to make the sentence make sense, right? So that's our original statement. Was that original statement true or false? All right, so we got that. Now we want the converse first. What's the converse do to a statement?
Switching.
Switches the hypothesis and the conclusion. What's the hypothesis in this case?
If the
So
sum,
if
if the
two
sum,
angles are
Close.
if the sum of two angles,
if two angles are complementary.
What do you leave off?
So two angles are complementary.
That's the hypothesis.
I thought we were doing the converse.
We will here in a second. What's the conclusion?
Sum is
Sum is 90.
Now, to do the converse, you told me to switch those two, right? So how am I gonna write that? Now say it.
If two angles, if the sum of two angles is 90, then they're complementary.
I gotta get rid of that thing. Can't write with it that way. Is that true or false? If you got two angles and they add up to 90, are they complementary angles? False?
Wouldn't that like be like if they were both 45 or like
If they're both 45, they add up to 90, right?
Wouldn't it be true?
Are they
if you have
complementary?
two of them that are 90 degrees?
No, no, what's it say?
It's true.
If the
Yeah, it's true.
Just
sum of two angles.
It's, cause it
Well,
can
then
be
Any two
Sure.
angles add up to 90 degrees,
Yeah,
and
it's
basically, any two angles that add up to 90 are complementary.
So is it true or false?
True.
True. So anybody remember? My son's taking a test over this stuff today and he asked me for sure what this was. If the original statement's true and its converse is true,
by
it's biconditional. Biconditional. What's the inverse do to a statement?
negate.
Negates both parts. So what's that gonna say? I'll help you out.
If two angles are not complementary.
Two angles are not complementary, then what?
Then they do not equal 90.
Then the
The
sum
measure
is
is
not
not
90.
Yeah.
Then the sum is not 90 degrees. Is that true or false? Yeah, these two angles, they're not complementary to each other.
It's true.
It's true, yeah. So you got two angles, they're not complementary. Maybe you got a 20-degree angle and a 30-degree angle. All right? Are they, if they're not, we know they're not complementary. Are they gonna add up to 90? No. And the contrapositive. What's the contrapositive do to a statement?
Switches and negates.
Switches and negates it. Now, I think I mentioned this last time. The book will tell you that the contrapositive is the converse of the inverse.
That is confusing.
And if that confuses you, then close your ears so you don't hear the rest of what I'm getting ready to say, because that might be easier for some of you. Some of you probably, maybe not, some of you, yeah. I always go back to the original statement so that I make sure I don't get confused. But if you look at the inverse, all the contrapositive does to the inverse is the same thing the converse does, switch the hypothesis and the conclusion. So if that helps you, you can do it either way.
If the sum is not
If
90.
the sum of two angles is not 90.
All right, so it'd say this part first, then that. So
If the sum of
if-
two angles is not 90 degrees, then it is not.
Then they're not complementary.
sum of two angles is not 90 degrees, then what?
They are not
They're not.
complementary.
They are not complementary. Is that true or false? You got two angles and their sum isn't 90. Does that mean that they can't be complementary to each other? Yeah, that's true. So in this case, all four of them ended up being true. The original statement and the converse, inverse, contrapositive Next question.
47.
Which page? We need to do a 47.
We did it?
Which page you thinking and I'll do it? Is that on the first page, 78?
I have 47 wrote down.
Wait, what problems all did we do?
28, 30, 34, 36, 40, 42, page 85, 12 to 26.
Did you write 47 and 40? Oh, no, I wrote 42, but it was like a 7. Oops.
Questions, other questions?
It doesn't quite work fast.
Okay, so like, if we can't reach like a, whatever you call it, is it like, is it no conclusion or no, like?
You could put no conclusion or you could put invalid. Invalid is what the book says all the time. I just write no conclusion. So
When we put that.
Or could we do like this?
When we put that.
if you can't draw, if you can't say something like, if I say.
Okay,
if-
I remember us doing this yesterday. Like, if it, I can't think of the example we used, but.
If I give you a statement like, in this room there are 26 desks, how many elephants are in the room?
0.
Well, you don't know, because the statement that we made
It's not that.
didn't have anything to do with that, so we can't say.
Wait,
Because there was like a
what do you mean?
couple.
There is
Yeah,
no
yeah.
elephant.
Yeah, there is. I got a picture of one back there on my desk.
Yeah.
18,
Well,
but
we
every
can't
day or
see
something
it.
like that.
Oh,
Yeah,
that
let's
mean
do the
anything.
word, I don't know what problem it is, but it says something about if you're 18, you vote on everything, it's fine.
Somebody, which one is that? Somebody help me find it. I'm not gonna ask what you two up on. I think I am.
We're good. Oh, it's, no, that's not it.
28.
28, on which page? Which page? 79. 28, determine the truth value of the following statement for each set of conditions. So they're giving us this rule, and we're just taking it for granted. We know it's not always true in real life, but for every problem, 28 through 33, we're taking it to be the law, nothing else. If you are over 18 years old, then you vote in all elections. So 28 says you are 19 years old and you vote. Is that going to be true or false?
True.
True. 29 says you are 16 years old and you vote.
No.
That's false. Because did they tell us anything about a 16-year-old? No. They said if you're over 18, so that's all we can make decisions about. 30, you are 21 years old and do not vote.
No solution.
That's false. Because if you're over 18, what did our law say?
You vote.
You vote. You vote in all elections. Now, we know that that's not true, right? Only about 30% of all people vote when it comes to election time.
Oh, I didn't know that was the.
But for what we're doing here, our rule says if you are 18, then you must vote, right? 31 says you're 17 years old and do not vote.
True.
Be careful.
You're 17 years old and do not vote.
Did they tell us anything about any 17-year-old? No.
So it
So
has to
that
be-
one, we have no conclusion.
So you
Wait,
have
I
to put
thought
in a
six-
keyword over if you're 18
Right.
or older, it's true. And unless it says you don't vote.
Right.
But if you're younger, it's no solution.
Well, not necessarily, because like 16.
Yeah, 16 and 17 are the same thing, but it says 17 instead of 16, doesn't it? No.
No, it says you vote for 16 and you do not vote for 17.
Oh.
Wait, what was 16 or,
So it has to do with true and false?
So maybe on that one, maybe we shouldn't have said false on that one.
What page is this on?
So
79.
let's go back to that one. You are 16 years old and you vote.
False.
It's
Because
false.
you can't vote when
Yeah,
you're
you
16.
can't
Now, hold on.
Because you can't
Because we're
say
going
that-
by 18.
No,
But all it
you're
says
going. No,
is
you're
you-
going by what the rules are in our actual real world.
But
Did
aren't-
they tell
Wait,
us
I
that?
thought you said that we only.
What did it say, Katie?
It's just saying if you're 18, you do vote. Like if you're older than 18, you do vote. It's not saying if you're 16, you don't vote. It doesn't show you any problem.
I
So
thought
that should
we
be
were
no.
going all.
So that one should have probably been no
Solution.
solution or no conclusion. Because do we know anything about 16-year-olds? No, they just said that if you're 18 or over, we know you must vote. So if you're 16,
You can vote.
maybe, all right? I'm not sure, and there are some 17-year-olds in our country, and I know this doesn't have anything to do with this. There are some 17-year-olds in our country who do get a vote, because if you're 17 and you're in the armed forces, can you vote? Yeah.
I thought we went off the book. I thought that's what you were explaining to us last
Right,
time.
and that's what I went back and fixed 29, because that 16 one you said.
But I thought you said we're going off real life.
No, I said if.
rules.
No, well, the
I
book.
I
the
said
book
that just a second ago,
only-
just
The book only talks about 18 and older voting. It doesn't say anything about you're not able to vote if you're younger than 18. It's not saying that.
Right. So we can't make decisions on that. So you're right, all we're doing is going by what the book says.
I think the key is not to like overthink it.
Exactly. Don't start thinking about stuff that it doesn't say right there.
Well, I know that, just you were like, we're going off real life.
Well, I
rules. So
said
was
that,
like,
I said some people in our country at 17
Well, I know
are
that. I
allowed
was
to vote,
talking
so
about
that was,
why.
I'm not explaining it again, I just explained it. Where
So
were
you
you
go
at? You
for
were sitting right here
they're
beside me
fighting for our
and
country.
didn't hear me say it.
Wait, how do they get to? Oh, no, they graduate. They're 17.
If
Never
they
mind. I was
graduate
like,
early and
that
they
means
go into the
dropped
armed
out.
forces, then,
How do you have? Is there an age limit for armed forces? You just have to graduate.
No, there's an age
Uh,
limit. For the Marines, you have to be, I think, at least 18. Because
I don't know if that's true or not, but
I'm
Because I
pretty
was
sure.
thinking
There
you
is-
like graduate when you're 16.
there is an age limit, yeah, they're not gonna let somebody graduate at 12.
Yeah, because
Join the
I'm pretty
Marines.
sure there is in the Marines because
Yeah.
Josh had to sign up. He signed up his junior year, but couldn't actually go in until he was 18, so we had to wait.
Next
Do
question.
you graduate when you're 12?
So right after he graduated,
I could.
so right after he
You guys could.
graduated, he
If you're
went
really smart.
into.
So like back in
And
the
you get all
day,
your credits.
They
when
only
you're
made it to, like,
13. Yeah,
eighth
if you're
grade.
smart.
Other questions, we're wasting time.
Kinsey Rice
Nah.
graduated.
How old is she?
No other questions. Everybody understands all that. All right. You know you're gonna sit out in the hallway here in a minute, right?
Seriously? If
Yeah.
I sing?
And I'll leave the door open so you can see through there right
What
now.
happens if you sit out in the hallway? You get in trouble.
Yep.
How much trouble?
Attention.
Oh, can I go get my tabs now?
Hurry. All right, what I want you to do, on pages 89 and 91, and I'm going to go back through this again, just so you can understand it. No, I will not explain it to Ariel again when she gets back in here. You got your
Go to
things
the-
here.
which one?
notes? And I got all my notes written down here. You probably got more than that now. Then my second section, postulates and theorems. And we haven't written anything in there up till now. All you're going to do, I put the pages up here, 89 to 91. So if you look at 89 and 91, you'll see that there's these little yellow boxes, and they got postulates and theorems in them. Flip on back, and there's more of them, more of them, more of them. Huh?
You're talking about.
Look in your book and you'll see it. So these aren't too bad. These first ones aren't real bad if you copied them off page 89 through 91. But for the whole year, it's going to be much, much easier if you go to the back of the book, and there's a purple section. Does everybody see this purple? There's a purple section, and in that purple section, it lists all the postulates and theorems. So if you jump back there right now, all you're going to do is you're going to copy that postulate, that next one, and what you're going to do is all the way down through the midpoint theorem. That's the last one. So that first theorem is going to be the last one that we copy for today. Does that make sense to everybody?
So if we copy them all now.
Yeah, you could copy more of them if you wanted. Now, the bad thing with that is, don't complain when we get to one of them and I say, oh, we're going to skip this one so you don't have to copy it. And then Chloe goes, well, I already copied it. Well, Mr. Eversole doesn't want to, I don't want to hear that because I didn't tell you to copy it, right?
That was really good. That was really good. And really dramatic.
So, well, that's the way you guys are sometimes, right?
We're girls, what do you
Copy.
expect?
Copy postulates and theorems off those pages. Again, it's easier if you get it out of the back. When I'm copying them down, I might do something like this. The first one is like postulate 2.1. Then I would write postulate 2.1 and just shorten it up.
You write 2.1 through 2.7.
And then just write it down, whatever it is. All right? So, go ahead. I'll give you a couple minutes to do that. You don't have to write the page number at the end of them unless you want to. Maybe Olivia up here, maybe that helps her know, hey, that was in chapter 2, or that was in whatever. Right, it's always
Okay.
it'll always start with 2 if it's in chapter 2.
We have to write all of these? No.
You're getting ready to write more of them. I'm going to make up some and make you write them down if you keep complaining.
Wait, am I doing this right? You just write 2.1 through 2.7 to the midpoint theorem things.
Okay.
So, we're not going to do this part. I love it so much when they fix my computer. Everything's different. We're not going to do that part today. When we do write down postulates and theorems, I will tell you, copy these down into your postulates and theorems section. Whenever we're writing down notes, like we are right here, it doesn't matter. Maybe the next slide says postulate 2.1 or 2-1 or whatever. Do not put that in your postulates and theorems section. Anything that's on this slideshow goes in your notes section. Does that make sense?
Yes.
Don't. So normally, when I do give you postulates or theorems, I probably talk about them, right? I don't just give you something and then not tell you what they mean or go over them. So at some point, whenever we have postulates and theorems, they will be in the notes. So that'll be like my explanation of them. What you copy down in the postulates and theorems section is the direct, exact postulate or theorem. Okay? That makes sense to everybody. Olivia, that doesn't make sense? All right, what we're going to cover today, we're going to talk about postulates and theorems. Be able to use and define postulates and theorems. If you looked on Moodle here in the last couple of days, you noticed probably that if you look through there and look down at all the things that are on there graded, one of those things says vocabulary test. But it's got a blank by it right now because have we taken it yet? No. But we haven't taken it yet. What do you know is going to happen here real soon? It's going to happen real soon.
On just this recent unit.
Yeah. Well, no, it'll be over everything.
Oh, that's it. We don't have any.
And anytime we do vocabulary tests all year long, like we'll do one last 2 weeks of school. And does it just cover that last part that we're on? No, it covers the whole year because when we get to the last 2 weeks of school, should you have forgotten what supplementary angles are? No. Should you have forgotten what complementary angles are? No. Should you have forgotten, parallel lines or any of that stuff? No.
Is this like
Yeah, know all this.
matching?
No, not usually.
You write it yourself.
Sometimes it is, not always. Depends.
Do we like?
There'll be, there's all kinds of different ones. Some of them, not always. All right, so we're going to talk about using and defining postulates and theorems today. The first thing, a postulate. And I'm going to give you my definition, and then we'll pop up another definition. I'd rather you write down my definition. I forgot that I even had the book's definitions on here. A postulate. So when we go to take this vocabulary test here in a week or so, guaranteed postulates on there and theorems on there. This is what I want you to write. A mathematical statement, and you could probably just write statement, I don't care. Mathematical statement That is taken to be true. What do I mean by that? It's taken to be true.
Maybe like they say it's true in the book, so you just have to assume it's true.
Right, so we just take it for granted that it is true. There's no way for us to prove that a postulate is actually true. We just take it for granted that it is true.
Are you going to make us a paper with all the vocabulary on it that was
Right.
done all year? Okay.
Will you tell us like the words?
Probably not.
Okay, because I was gonna go through my notes and just make, like, type them out, because I don't wanna have to, like, go back through my notes and stuff, but if you're gonna make one, I'll be mad that I, like, took time to make it, so.
If I put something on a vocabulary test, do you think it's something that we use? Yeah, probably quite often. All right? I won't put something on a vocabulary test that we used once and then never did anything else with it. So when I put something on a vocabulary test, it's something that you should know every day when you walk through that door what supplementary means, what congruent means. All right? If you don't know what congruent means, are you going to do very well in here? No. If you don't know what supplementary angles are you going to do very well in here? No. It's going to be stuff like that. Don't make it harder than it is. All right?
So are you like gonna tell us what this is gonna be, or are you gonna, we gotta like walk in, you're gonna say we're gonna?
Sometimes both.
Okay.
Oh, wow.
Back in second grade, first grade, whenever it was, you learned 2 + 3 = 5. Did you ask your teacher, well, why does that equal 5? No, that's sort of like a postulate. Your teacher told you that, you knew that was like a rule, and you just took it for granted to be true.
Well, it is true.
All right? So prove it to me.
Because that's how we.
1, 2. 1, 2, 3.
How do you know that that's 3?
Cause
That's how it is, and.
That's
how
how
the-
we've been taught.
Yeah.
Exactly, thank you.
And we
And
don't
you,
wanna go away. because
Aristotle-
and
that's
you just
here,
taught
that's
that.
been
No,
true.
Aristotle didn't tell anybody that the 3 stood for this many. That's not the way it works. Right? So you just took it for granted that these symbols added together gave you this symbol, right?
Yes.
We didn't try to figure out why or explain why, and your teacher didn't try to explain to you why. That's just how it is, okay? The other things that go along with postulates, you might want to jot this in. Somebody already asked about one of them. You have axioms and you have corollaries. Am I spelling that wrong? Corollaries. However it's spelled.
Oh, that's the word in the back of the book.
Right? Anytime you see an axiom or a corollary, call it a postulate. We're not going to separate those 3 things. So I'll never ever ask you what's the definition of an axiom or what's the definition of a corollary.
So axiom and corollaries are postulates.
Right? We're going to treat them just like postulates. So anytime you see an axiom, if the book says this is an axiom, I don't want Sophie to say, Mr. Ebersole, you told us to write the postulates and theorems, we don't have to write this axiom then, right? That's what, no. Treat it like it's a postulate. Okay? So all 3 of these, things that we just sort of take for granted to be true. They're going to tell us some things. Hey, this is a postulate. What did the first postulate say that you wrote down?
It said something about there's exactly 1 point.
Through any 2 points, there is exactly 1 line.
So through any 2 points, we pick any 2 points in the world.
Seriously, I write through any 2 lines. There's
Ha- You might want to change that. We pick those 2 points. How many lines are there in the world that go through those 2 points? 1. We talked about that earlier this year, right? Do we really want to try to go through and prove that that's true? No, that means we'd have to pick every single point or pair of points in the world everywhere and show all of them. And that's impossible. So that's what a postulate is. Something that you just take for granted that has to be true. Now their actual definition says this, I don't want you to write this down. A statement that describes a fundamental relationship between the basic terms of geometry and are accepted as true.
So they're saying it goes back to fundamentals.
All right, so all it's saying is use the general ideas in geometry, and it's something that we just accept to be true. So I just found the easier way to describe that instead of writing all that out. What do you think a theorem is? If a postulate's something that we just take for granted is true, what do you think a theorem is?
They're proven to be true.
Right. So a theorem, when we write the definition of a theorem here, I'm going to write sort of the same thing, a mathematical statement that must be proven true. So apparently some guy named Pythagoras did what a long time ago? He made a theorem. So what did he have to do to make that theorem? He had to prove it true. He didn't just walk out of his house one day and hand it to all the other mathematicians and say, here, this is true. And they looked at him and said, really? How come? And he says, because I said so. That doesn't work that way. He had to prove that for all right triangles, a squared, the length of one of the legs, squared, plus the length of the other leg squared, has to equal the hypotenuse squared. So, are these too hard to remember? Postulate, statement that we take for granted is true, theorem, something that you got to prove true. This is their definition. Statement or conjecture that can be proven true by using undefined terms, definitions, postulates, so on, so on, so on. Same idea, just less wordy. What does the second one say? What does the second postulate or theorem say?
Through any three planes not on the same line, there's exactly one plane.
All right, so through 2 points, any 2 points make a what? Line. Any 3 points make a plane. Now, any 3 points that are non-collinear. All right, so in other words, what's non-collinear mean?
Not on the same line.
Not on the same line. So if I was to pick 3 points, I couldn't pick 3 points that were right there on the same line because there's a whole bunch of planes that could contain that. I'd have to pick like a point here, and maybe a point over here. The only plane in this whole world that contains all 3 of those points is my whiteboard. There's no other plane anywhere in this world that contains those 3 points that I just drew. What did the next one say? A line always contains at least 2 points. So can a line ever be 1 point? No. As a matter of fact, a line, is it ever really going to be 2 points? There's always going to be millions and millions and millions and millions of points, right? But they're saying at least 2 points. The next one probably says something about a plane containing at least 3 points, right? Not on the same line. What's the next one say?
If 2 points lie in a plane, then the entire line containing those points lies in that plane.
So if I have this point and I have this point, they're on my whiteboard, that plane, right? If I connected them, every other point that's on that same line lies in what plane? The whiteboard. That's all that says. Are you noticing anything with postulates? They're sort of what? Just common sense stuff, right?
Yeah.
They're stuff like you think, well, no kidding. That's a lot of what postulates are. What's the next one say?
If 2 lines intersect, then their intersection is exactly the same.
So if you got 2 lines, they intersect. Where do they always intersect at?
The middle, well, 1
Sorry.
point.
Exactly
1 point.
1 point. If you got, maybe does the next one say if you have 2 planes, how do 2 planes intersect?
Their-
At a
their
line.
intersection is
Is that what the next one says?
if 2 points intersect, then their intersection.
This is all stuff we talked about in chapter 1, right? 2 points make a line, 3 points make a plane, 2 planes intersect at a line, 2 lines intersect at a point. Now the theorem, the midpoint theorem. What is a midpoint? What is a midpoint? Just explain that to me.
A
Be
point-
careful.
A point that splits
A point that splits what?
a line.
Ah,
Anything?
no.
Point.
Point that splits what?
A segment.
A segment, thank you. You can't split a line. Point that splits a segment into
Two equal halves.
two equal segments or two congruent segments. And that's what the midpoint theorem says, is if M is the midpoint of segment AB, then segment AM has to equal segment MB. Or has to be congruent to segment MB. Even that one. Was that a real hard one? No, but that, so the difference is that theorem is something that had to be proven true, whereas all the rest of them are things that we just took for granted as being true. All right, a proof.
Do we have to write the vocabulary part too?
No, you don't have to write that. Just write proof. A proof is a logical argument, and I know I spelled which wrong, in which each statement you make is supported by a statement that is accepted as true.
You want us to write that?
Yeah. We're going to do 3 different kinds of proofs. Actually, we're going to do 2 different kinds, but the book's going to talk about 3 different kinds. The kinds of proofs. Today we're going to deal with paragraph proofs. What do you think a paragraph proof is? Where you write a what? Paragraph. Real hard. Math people so creative. The other one, a 2-column proof. What do you think you have to write in a 2-column proof? 2 columns.
Like a T chart?
Yep, that's exactly what it is. And then the third thing is a flow proof. We're not going to do flow proofs because I don't like them. So in English class, you've probably done flow charts for like a story where you had the main idea and then maybe branched off of that is all of the characters, and then off of them was what they did in the story. I don't know how it works in English class, but something like that maybe. So anytime, my whole point here, anytime for the rest of the year, because I may forget, getting old and I forget a lot of things, anytime you see it say, write a flow proof, don't write a flow proof. Write a 2-column proof.
Wait, but
All right? So no flow proofs. Anytime you see it, if it's a problem I've assigned to you and it says write a flow proof, write a 2-column proof. Yes, Chloe?
Okay, a postulate is taken to be true, and then a proof is accepted as true. Isn't that like the same thing? Because we for the first one, the postulate, you said it was like being like, I just lost my train of thought.
a postulate would be like 2 plus 3 is 5, and then proof is like you're proving that 2 plus 3 is 5.
A postulate and a theorem. A postulate is a statement you take for granted to be true. A theorem is a statement that's got to be proven true. A proof is a way of proving something is true. All right, so this doesn't really go with the other 2. Does that make sense? So a proof is a logical argument. If you do a argumentative paper in English, you're trying to prove to somebody that your idea is correct over some other idea, right? That's an argumentative paper. That's sort of what a proof is. Only you're not trying to prove that you're right over somebody else in a proof. You're just trying to prove, hey, I know this information. Well, to go from here to what I want, I do all these things. Every time you solved the algebra problem in algebra last year, you did half of a proof. So every time you solve something like 2 plus 3 equals 7, you were doing a proof, you just weren't doing the whole thing. Okay? Because you were doing this. So you did that. The part you didn't do, you didn't make a statement that supported what you did.
What do you just say?
X equals 2 is the
And what you did do is you learned those last year, but you did them like the first day that you started to solve stuff like this, or 2 years ago maybe. And then after that, your teacher never talked about it. So for this one, to go from here to there, does anybody remember the rule that told us we could do this right here? Subtraction property of equality.
When did we learn about
Subtraction
that?
property of equality says that you can subtract the same thing on both sides of a equal sign. And don't tell me your teacher didn't tell you that.
I
I know
remember
they did.
learning about
No,
like.
no, I have to sneeze.
What you do to one side, you do the other.
Exactly.
I know
So-
that, but I didn't know that was.
I remember
So that's the
division
sub-
property of
And then what's this next one? What would we put here? What's our reason there?
division.
Division property of
Wait, what was
equality.
distributive?
When you like, it's outside of
Distributive property.
parentheses.
Alright, we're gonna go over that all here in a couple days, because we're gonna do a bunch of those and we're actually gonna write them out.
There's a two outside and,
Alright, a paragraph proof. Another name for a paragraph proof is an informal proof. And all a paragraph proof is what?
A paragraph
Proof.
Uses a paragraph to do what?
to prove it correct or
To
true.
prove something. That's good enough. Uses a paragraph to prove whatever. Uses a paragraph to prove something. And again, it's called an informal proof. Well, when we get to 2-column proofs, guess what they're called? Formal proofs. I have no idea why. Seems backwards to me, because if you're writing a paragraph, that seems formal. When you're making a T-chart, like you guys call them, that's sort of like an outline, right? That would be informal, but it's backwards.
I just kind of wrote paragraph proof.
All right, a good paragraph proof has 3 things. Or 5 things,
Are
not
we
3
writing
things.
these down?
Yep. And I'm just gonna go ahead and put all 5 of them up here and go through them all at once, because they're not that difficult. It's just like writing a paper in English class. What's the first thing you start off with if you're writing a paper in English class?
Thesis statement.
A thesis statement. And that thesis statement is what you're trying to prove in math class. So I want to prove that these 2 segments are congruent. Might be a way that I start something. Whatever it is you're trying to prove. Then where do you go after that on an English paper? What's the next major thing you write?
Evidence.
All right, your evidence. What's that called? Where's it located at? In the
Body.
body. All these things right here,
A hamburger.
all of those right there, I'm misreasoning, but that's like the body. You list all your given information, the stuff you know to be true. Maybe you draw a diagram. Are you always going to draw a diagram? No. Sometimes you might draw a diagram, sometimes you don't have to. If you're trying to prove something like that the Holocaust actually occurred, if you're trying to prove that the Holocaust actually occurred, are you going to draw a diagram? Probably not. Then you develop a system of deductive reasoning. All that means, big terms, all it really means is you make a statement and you give a reason why that statement is true. That's what deductive reasoning is. If I'm going to go home and ask my wife for $20, and I say, can I have $20? What's she going to say? Why? And I say, because I want it. That's not a good reason. And she's not going to give me $20. Right? So I got to give her a reason. I need $20 so I can pay for Chloe's fruit that I have to buy off of her. And then she'll probably give it to me. Okay, that's because you're a nice guy, and even though she hates spending money, she'll let me spend money on something like that, since I'm helping Chloe out. Even though she doesn't know Chloe, and
She loves me.
Then what do you do lastly? What's the last thing you do? Conclusion. You finalize it. You say,
You
I
basically
know-
your thesis statement.
exactly. what was my thesis statement? I was trying to prove that these two segments were congruent. So down here I say, I now know that these two segments are congruent because they have the same length, or the same measure, whatever it is. Alright, we're going to skip this for a second. We may come back to it. What would you do on something like this, just real quickly? Jessica is setting up a network for her father's business. There are 5 computers in her office. Each computer needs to be connected to every other computer. How many connections does Jessica need to make?
25.
25. That's what you do, right? You just
Yeah.
guess.
Well, I was
5
doing
times
5
5.
times 5 if they're all.
Is that going to work? What should you do before you just try to answer something like that?
You should
Draw it out.
Thank you. Draw a picture. So you got 5 computers. And this is where you guys are going to get yourself into trouble. You got 5 computers there.
Go one by one.
And you could connect each one. I'm not going to do it, but
It's 20.
Ruth Lemon to the office, please. Ruth Lemon.
that sounds like too many too.
Hi, Ruth.
So make sure you could go through and do that.
I did it twice.
I think you're wrong.
Yeah, I'll say 15.
All right, this is a quiz. Are you leaving, Ruth?
Yeah, we're running, well, we're going on the state course practice.
So make sure you write this down. This is a quiz that we're going to do in class. And then make sure you get the assignment off somebody or off me. This quiz, I'm going to let you do this quiz. We've got about 7 minutes. You should be able to get it done in that time. You can work together. You can help each other. Whatever you want to do. It's actually written over here on the side. I'm going to turn the lights back on and I'm going to switch the slide to the homework.
Wait, where to this one?
Yep. So this is a quiz, page 91, problems 4 through 11. This is your assignment for tonight, this right here. So go ahead and do the quiz. It's due before you leave. And make sure you got the assignment written down. All right, I wanted to go through these postulates and theorems. So this is, stuck this onto the end of this video. Just going to go through them real quickly, try to give you some idea. Postulate 2-1 or 2.1. Remember, a postulate is something you take for granted to be true. You just take it to be fact. Doesn't have to be proven. Through any 2 points, there's exactly one line. What this postulate's saying is you draw 2 points anywhere in the world, and no matter what, there's only one line that connects them. You'll hear me say a whole bunch of times, 2 points make a line. So anytime you have 2 points, there's exactly one line, or together they always make exactly one line. Postulate 2.2 says if you have 3 points that are all not on the same line, so they're non-collinear points, then those 3 points are all contained within exactly one plane. The plane here is the screen that you're watching. So all 3 points, when I drew them, they were all 3 on the plane that's your, whatever screen you're watching this video on. Postulate 2-2.3. And postulate 2.4 are sort of the reverse of 2.1 and 2.2. 2-3 says if you have a line, then there's always at least 2 points contained on that line. So 2-1 said any 2 points make a line. 2-3 says any line has at least 2 points or contains at least 2 points. 2-4 goes along with 2-2, and it's 2-2 said any 3 points make a plane. Well, 2-4 says sort of the reverse of that, which any plane has at least 3 non-collinear points on it. Now, you know that on a line, there's gonna be a whole lot more than 2 points on it. There's gonna be a whole bunch of points all the way down through there on a plane. There's gonna be all kinds of points on that plane. So there's a whole bunch of different stuff on there, but it's just sort of the reverse. These first two are the ones that you ought to make sure you know. 2 points make a line, 3 points make a plane. Next one, 2-5. Postulate 2.5 says if 2 points lie in a plane, then the entire line containing those points lies in that plane. So if we have a plane and you got 2 points on that plane, then if we connect those 2 points or draw a line through those 2 points, then that entire line and every point on that line, so every point on that line will be on that same plane. Postulate 2.6 says if 2 lines intersect, then their intersection is exactly 1 point. So all that's saying is if you have 2 lines, wherever 2 lines intersect, they can intersect 2 times or 3 times or 4 times, they always intersect at exactly 1 point. Postulate 2.7, see if I can draw this, says if 2 planes intersect, so if we have a plane, we'll call this one plane P. And we have another plane, probably can't really draw it. Yeah, my drawing's not gonna be very good. Yeah, that's terrible. See if I can redraw that. So we'll call this one plane P. That's terrible too. We'll call this one plane M. Well, where these 2 planes meet, or where they intersect, is always going to be exactly 1 line. Can't look at my picture because I'm not an artist. Can't look at my picture and think about the ceiling and the floor. Where they come together, those are both planes, and where they come together is a line. So anytime 2 planes intersect, they form a line. Anytime 2 lines intersect, they intersect at a point. And then the last one, the midpoint theorem. Midpoint theorem. Remember, a theorem is something, a mathematical statement that has to be proven true, where a postulate is something that we just take for granted is true. The midpoint theorem says if you know a point is a midpoint, so if I know M is a midpoint of segment, and they use, in the book, they use, I think segment AB. So if we know that M is the midpoint of segment AB, then we know that segment AM has to be the same as segment MB, or segment AM is congruent to segment MB. Remember, that means the length of AM is the same as the length of MB. All right, the other thing I'm gonna go over here real quick is the quiz, page 91, 4 through 11. See if we can't run through those sort of quickly. Problem number 4. Says determine the number of segments that can be drawn connecting each pair of points. They give us 4 points. Alright, let's even label the points. We'll call that A, that B, that C, that D. Well, we want to connect A to B, we want to connect A to C, we want to connect A to D. So far we've got 3. And we want to connect, we've already connected B to A, so we want to take B to C and B to D. So we've got 2 more there. And then we want to connect C. It's already connected to B, it's already connected to A, so we want to connect it to D. We got 1 more. So the answer for number 4 is 6. Number 5. They give us 6 points. And we want to know how many points it takes to connect those. So we're going to connect this one to there, this one to there, this one to there, this one to there, this one to there. 1, 2, 3, 4, 5. So we've done 5 so far. Connect. We've already connect that one to there, that one to there, that one to there, that one to there. So 4 more. Then connect this one to here, this one to here, this one to here. It's 3 more. Then this one to here, this one to here. It's 2 more. And then this one to here. Notice there's a pattern there. So 9, 10, 11, 12, 13, 14, 15 be the answer to that. Number 6. Determine whether the following statement is always, sometimes, or never true. Explain. The intersection of 3 planes is 2 lines. That could be true if you think about 2 walls and the floor. They intersect at 2 separate lines. But it could also be where you have 1 plane, then you have another plane, and then you have a 3rd plane, maybe that looks like this. And if they all intersect right there, then they only intersect at one line. So this one would be sometimes. Sometimes it does, sometimes it doesn't. And you could also have, if you think of the floor, the ceiling, and the floor in the room below us, they're never gonna intersect. So again, it would be sometimes. Number 7. And 7, 8, and 9 uses all the same plane, so I'm gonna draw it up here real quick. Change colors here. Got a line that let's draw this plane again. Got a line that goes through here, something like this. And it's got D, B, and W on it. Got a ray, comes out here, looks like that. That's R. Then you got a line that looks like it goes, sorry, that should be dotted. So that right there should be dotted. It goes through the plane. And you got E out here. And W down here somewhere. Number 7, ask us. It says, in the figure line BD and line BR are in plane P, and W is on line BD. Oh, that's not W. W's up here. That's not W. State the postulate or definition that can be used to show each statement is true. The first one, BD and W are collinear. BD and W are collinear. And the reason we know that they're collinear is just definition of collinear points, which says collinear points are points on the same line. Number 8 says E, B, and R are coplanar. So E is out here, B is right here, and R is right here. Notice that these don't all lie on plane P, but we had a postulate that said any 3 points make a plane, or the postulate actually said are contained within a plane or something like that. And that would have been, if you wanted to go by the number, which I'd rather you didn't go by the number, that would have been postulate 2.2, because you won't remember the numbers after a while, but if you remember the rules, that'd be better. Number 9 says R and W are collinear. Doesn't even matter where R and W are, but R is there, W is here. And the reason we know that is any 2 points make a line. And that was postulate 2.1. Number 10. Says in the figure at the right, P is the midpoint of segment QR and segment ST, and QR is congruent to ST. Write a paragraph proof to show that PQ equals PT. So the way we're going to start this paragraph proof is something like, we want to prove PQ equals segment PT. So we have our thesis statement, I think you call it in English class. Then maybe we do something like, and my English isn't very good, so we know that, and we just state what they told us. Excuse me. P is the midpoint of segment QR and ST. And we may want to draw the diagram in here somewhere so that we can use it. Got QR. Got ST. P's right here. And we write something like since P is the midpoint of segment QR, we know if it's the midpoint of this segment right here, QR, and we know this segment's congruent to that segment, so we know that segment QP is congruent to segment PR. We can go from there, and we say something like, since P is midpoint of ST, segment ST, then we know segment SP is congruent to segment PT. Now, what's different here, or what we have to do that I haven't done yet, is we need to give a reason for that. So maybe I put a comma here and put something like, we know both these because a midpoint splits a segment into two congruent segments. I'm gonna come back over here, start writing again. Now, there's some other given information that I didn't use yet, things that they told us. They told us that segment QR was congruent to segment ST, so this whole thing is equal to this whole thing, that whole segment. So I'm gonna use that over here and start writing over here. Let's put a little line here so we were told segment QR is congruent to segment ST. Well, if that's the case, if we know that this whole length is the same as this whole length, and we split this length in half, and we split this length in half, then we know, so I'm going to put a comma here, so we can say that all 4 of the shorter segments are congruent using the transitive property. And I'm going to put down here, maybe put in parentheses or something, it doesn't matter. Then we know that segment QP is congruent to segment PR, which is congruent to segment SP, which is congruent to segment PT. So we know all 4 of those are congruent. And I might say something like, therefore, we can say that the length of, what segments did they ask us? Of PQ is equal to the length of segment PT. Give me a minute. Because congruent segments have equal lengths. Alright, the last one, number 11. 6 students are participating in a dance to celebrate the opening of a new community center. The students each connected to each of the other students with the wide colored ribbons will move in a circular motion. How many ribbons are needed? So number 11, we got 6 students. And we're gonna connect them to each of the
Mr.
other
Sanderson,
students.
call the office, please. Mr. Sanderson, call the office.
And they wanna know how many ribbons are needed. So if we connect this person to that person, this person to that person, this person to that person, took 5 ribbons. Then to connect this person to each one, it's gonna take 4 ribbons. Connect this person to each one, it's gonna take 3 ribbons. To connect this person to the last 2 that they're not connected to, 2. And then to connect these 2 people, 1. So 9, 10, 11, 12, 13, 14, 15. I think that was the same answer we got when we did it, doing 6 on the other one. So that's the quiz.